So today we're here with our Junker test bench, and with this we're going to be demonstrating the benefits of the HYTORC J-Washer. In the bolting world, there's a lot of different applications where the bolted joints will be going under some sort of vibration, and over time, if you're not using a locking feature like the HYTORC J-Washer, those bolts will come loose, and that's definitely something that you don't want. We've got the knurls on the bottom side that's going to grab our application. We have our flower pattern around the outside that allows our tool to grab onto the washer, which eliminates the reaction arm. And then we have our top side locking knurl, which is specifically placed in this location along the inner diameter of the washer in order to reduce the load losses during torque from having a knurl on the top side of the washer. So looking into our test here, we have a 5/8 grade 5 bolt. It's pre-lubricated. We have our 5/8 J-washer here, and we've got our light hex nut, which is also lubricated. So to begin our test, we're going to install our washer, making sure that the tight knurls are facing out towards where the nut will be. Next, we are going to take our light hex nut, and we're going to run it down until we get about snug, hand tight, nothing crazy. Now we're going to move over to our Vibrationmaster test suite here. And the first thing we're going to do is we're going to align our bolt hole. Okay, that bolt has been centered. Now we are going to zero out our sensors. We are ready to start recording our clamping force. What I'm using here is a HYTORC Lithium Series 2 with a HYTORC washer driver. You'll notice the flower pattern on this outside can matches the flower pattern on our washer. That's what's going to eliminate the reaction arm for us. All right. We are going to stop our clamp force measurements. And now we are just going to clean this bolt off so we can mark it up so we can see if there's any kind of rotation when we begin our vibrations test. Just going to mark this up. Next, we're going to set up the actual vibration that the Junker test requires. We have a frequency of 12.5 hertz, and we're going to be doing this over 2,000 cycles. And the goal of this test is to stay above 80% of that initial clamping force. So we're going to set this up, go over to our vibration screen here, and you'll see our initial clamping force is at 49.3 kilonewtons, and we are going to start this vibration now. And as you can see, there is an initial drop-off on the load that is seen. That is due to the nut rotates ever so slightly, shifts into place, it locks into those top side knurls, and that's what prevents it from continuing to rotate off. And once it gets locked in place, you can see on the graph that everything levels out and we are good. Now, we have conducted tests with other types of fasteners. So we've done, a flat washer. We've done split washers. We've also looked into the elastic locking nut that people will use when they see vibration on their application. On the flat washer, those will vibrate loose very quickly. You lose load within 10 seconds of vibration. The split washer, it lasts a little bit longer. It holds load for a little bit longer, but still, in terms of the Junker test parameters, it fails, it comes loose. Same goes for the elastic lock nut. So with the HYTORC J-Washer, you can be confident that you're going to keep bolt load under vibration while also taking advantage of the other benefits of the HYTORC reaction washer. So the test is wrapping up here, and as you can see on the graph, we have that initial drop-off that I touched on, and then it flattened out, and the test has ended. That nut has not moved. That is a pass by all means on the Junker test, and we'll keep your bolts tight under vibration.